So let's talk a little bit here. I don't think I have my board with me. Oh, I don't. Must still be in my office. So today we are going to start arithmetic sequences and series. There are two branches, okay, or two types, if you will, of sequences and series, and that's arithmetic and geometric. Okay? Arithmetic we're going to do today and tomorrow and next week Monday. Okay? Then we'll have a formative and a quiz next week on arithmetic sequences and series, and then we'll start geometrics next week, Wednesday, week from today. Okay? So arithmetics today, day one, we're going to deal with sequences today. Tomorrow we'll deal with series. Monday we'll deal with application problems. Okay? So that's the plan. So sequences and series today are actually just really sequences today. A tall brick building has a decoration as shown. If each row is a foot tall, how many bricks will be in the bottom row if the wall was 15 feet tall? And how many bricks would it take to build the wall? Okay? Those are both applicable real-world type of questions that can be answered after this section. Okay? Both are great problems for this unit. Okay? Today we'll be able to answer the how many bricks are in the bottom row question. Tomorrow we'll be able to answer the how many total bricks there are question. Okay? And then we would give this problem like on Monday, because this would be an application type of problem. Okay? So first off, let's define what an arithmetic sequence is. An arithmetic sequence is a sequence that has a constant difference between consecutive terms. So the difference between the first and the second term is the same as the difference between the second and third terms, is the same as the difference between the third and the fourth terms, is the same as the difference between the 90th and the 91st term. Okay? That common difference, and that's what it's going to be called, is a common difference, is constant throughout the entire sequence. In other words, it's a sequence that adds the same number. Arithmetic, add. Okay? So we're adding a term to get the exact, or we're adding a number to get the next term every single time. Okay? So, in both of these cases, if I needed to state whether the sequence is arithmetic or not, I would have to look at the difference between the first and the second term. And that difference here, I'm adding 4. Okay? And then I would look at the difference between the next two. Again, adding 4. And then the next two. Again, adding 4. And the next two. Again, adding 4. So since these are all the same, this sequence is arithmetic. Okay? And that common difference that we were talking about before is 4. The common difference would be 4. Over here, again, I look at what I'm adding to get to the next term. And in this case, I'm adding negative 5, or I'm subtracting 5. Those are the same thing. Okay? Adding negative 5, subtracting 5, same thing. Again, subtracting 5. Again, subtracting 5. So all of these are the same. So yes, this is also an arithmetic sequence. Okay? Adding doesn't always mean we're getting bigger. Okay? All right? So, your turn. You tell me if any of those sequences are arithmetic or not. First one's always adding 10, correct? Okay, so that means it's arithmetic. Where'd you put the phone on? That's not a way. Plus 3 there, plus 5. Arithmetic, not arithmetic? No, because those two aren't the same. So that's a no. That's minus 9. This is plus 18. So that's definitely a no, because those aren't the same. This is minus 12. This is minus 12. This is minus 12. So a yepper. Yep. Agree with those? Question? Wouldn't what? Yep. Well, that's next week. And the question was just, is it arithmetic or not? Yeah. So, this is called the rule. You definitely want to write this down. You definitely want to put a big old star next to it. In fact, you probably want to put it in a box so that you can easily find it. Okay? This is very important. This is the arithmetic rule. You are going to use this for the remainder of this unit. Okay? The rule states A sub n, that stands for any term or the last term or the term that you're looking for, is equal to A sub 1, the very first term in the sequence, plus n minus 1 times d, okay, where n is the number of terms and d is the common difference. If I ask you to find a rule for a specific sequence, I am going to be asking you, if that sequence is arithmetic, to use this formula and give me an equation for A sub n in terms of n. Okay? So in order to find said rule, you are going to have the first term. You need to have the first term in order to find the rule. You must have the common difference in order to find the rule. You gotta have those two in order to find the rule. If you don't have those two, you have to algebraically find them. And we'll go through the different scenarios of how to find those today. Okay? All right, here we go. So, write a rule for the nth term and then find the 20th term. Okay, we can handle that. So there is our rule again. We need the first term and the common difference. The first term, when it's listed out like this, the first term is that very first number. And that's your first term when it's listed out like that. Okay? The common difference is going to be what it takes to get to the next term. In this case, the common difference, D, is positive 2. We're adding 2 every single time. My OCD is kicking in. Move this out of the way here and this way. Those were supposed to be purple. Okay. So my rule states now A sub n is equal to my first term. My first term was 1 plus n minus 1 is going to stay n minus 1 because we don't know what n is. We're finding a general rule for any term in this sequence. So n is going to stay n times my common difference, which is 2. Okay. Now, we like things simple, so we're going to simplify that rule. So this will become 1 plus 2n minus 2 when I distribute the 2 into there. And that would give me a rule of A sub n is equal to 2n minus 1. So that, ladies and gentlemen, is the rule for this sequence. Then it said, find the 20th term. So now I'm going to use my rule, and I'm going to plug 20 in for n. Twenty times 2 is 40. 40 minus 1 is 39. So the 20th term in this sequence would be 39. Yes? Questions, comments, concerns, clarification? Your turn to try one. You find me the rule and the 20th term on letter B. I get a common difference there of -4 because we're subtracting 4 every time. So utilizing my rule, A sub n is equal to 6. That's my first term, plus n minus 1 times my common difference of -4. that would be, I went green then, so 6 minus 4n plus 4 is going to give me a rule, a sub n is negative 4n plus 10. Using that then to find the 20th term, negative 4 times 20 is negative 80. Negative 80 plus 10 is negative 70. Questions, comments, concerns, clarifications? Okay. Another style of problem would be one like this, where we give you, or I give you, any term in the sequence. And I give you the common difference. Okay? So what this is saying right here is, this is saying that the sixth term is negative 16. If the sixth term is negative 16, then that would be any term in the sequence. A sub n stands for any term in the sequence. So negative 16 here would be the sixth term. Well, I don't know what the first term is, but I do know that negative 16 is the sixth term. And I know that my common difference is 9. So I can set up my rule. I can use the rule to find the first term. 6 minus 1 is 5. 5 times 9 is 45. So negative 16 is equal to a sub 1 plus 45. Subtracting 45 from each side, I get the fact that a sub 1 is, what would that be, negative 61? That's it. 61? Yeah, negative 61. Now that I have that, I can reuse my rule, and I can say that any old term a sub n is equal to negative 61, that's my first term, plus n minus 1 times my common difference of 9. That would give me negative 61 plus 9n minus 9 would give me any term in this sequence is 9n. Oops, I put minus 61. That should be minus 70. Then the directions went on to ask us to use our rule to find the 18th term. Oops, put the parentheses in the wrong spot. It's a big difference. Nine times 18 is 2, carry the 7, 162. 162. 162 minus 70 is 92. you want to call it. Okay. With that being said, find me the rule for the sequence, given that a sub 12 is negative 3 and the common difference is negative 7, and find me the 18th term. So the 12th term is negative 3. So negative 3 would equal a sub 1 plus 12 minus 1 times my common difference. My common difference would be negative 7. So, doing that, 12 minus 1 is 11. 11 times negative 7 is negative 77. So negative 3 is equal to a sub 1 minus 77. Add 77 to both sides, and I get 74 as my first term. If 74 is my first term, then I can reuse my rule. A sub n is equal to 74 plus n minus 1 times my common difference of negative 7, and that would give me 74 minus 7n plus 7. So my rule here would be negative 7n plus 81. Finding the 18th term, right? 18, yep, 18th term then. Negative 7 times 18 plus 81. Negative 7 times 18 plus 81 should give me negative 45. Yes? Love it. Okay. One last style of problems, and that is when you're given two terms. So if you're given two terms somewhere along the way, somewhere in the sequence, what you have to do is you have to write a system of equations using each term. So for instance, I would take this, the 8th term is 21, and I would say that 21 is equal to a sub 1 plus 8 minus 1 times d, utilizing my rule. So I could simplify that to be 21 is a sub 1 plus 7d. Then I would have to take the second term that I'm given, and I would say 97 is equal to a sub 1 plus 27 minus 1 times d, utilizing my rule. So 97 here is a sub 1 plus 26d. There is my system of equations. My two variables are a sub 1 and d, the two things that we need to write our rule. So we need to solve those, or solve that system. We've got graphing, we've got substitution, we've got elimination, we've got matrices. Whichever way you choose, whichever way you feel is the best to solve, I would take this first equation and I would multiply it by -1 if it were me. Then I would take the second equation and just leave it as is. Add those two together, and that gives me 76 equals 19D. Divide both sides by 19, and I get 4 is my common difference. If 4 is my common difference, 21 equals 4, that breaks, equals a sub 1 plus 7 times 4. So that is 21 equals a sub 1 plus 28. So -7 is my first term. Actually, that should have been red. Whoa. If that's the case, then a sub n is going to equal -7. Oops, I need to move that over a little bit. It's going to get tight there. Plus n minus 1 times 4. -7 plus 4n minus 4 gets me my rule. Here is a sub n is 4n minus 11. Okay. And we can find the rule given two terms. Okay. Questions, comments, concerns on that one? Try that one. Find me, oops, do we have to find the rule? Nope, we just had to find that. Okay, so you find me the rule and find me the 25th term. So that's saying 31 is equal to the first term plus 4 minus 1 times d. 31 is equal to the first term plus d. Yeah, this one is saying that 85 is equal to the first term plus the 10th term. D, so that is 85 is equal to that plus 9d. I would take the top, or the blue one here, and then multiply it by -1 again. Keep the green one the same. Add them together, that's 54 equals 6d. So I get d is 9. If d is 9, then 31 plus, oops, tap the brakes. 31 is equal to the first term plus 3 times 9. 3 times 9 is 27. So that gives me 4 is the first term. If 4 is the first term and 9 is the common difference, then my rule would be 4 be n minus 1 times 9, which would be then 4 plus 9n minus 9, which would be my rule would be 9n minus 5 would be the rule. And we needed to find the 25th term. Nine times 25 is 225, minus 5 is 220. So the two answers that we're looking for are that one and that one. Yes? Yeah. Now, I will tell you that I was just perusing the worksheet this week, and I used the program that I have on my computer to make it, and they don't call it a rule. The worksheet doesn't call it a rule. They call it an explicit formula. Same thing. Explicit formula is the same thing for a rule. Okay? I call it a rule because it's one word instead of two, and I'm lazy. Okay? So with that being said, now yesterday, you should have 1 through 6 done on the worksheet. So now you should be able to do 7 through 12 on the worksheet. Okay? So you should be through number 12 on the worksheet. Okay? All right. So that's all I got for you today. So thanks for playing along, and we'll see you next time tomorrow.